Good morning. I'm Dr.P.Elaveni from here, and today we will be discussing on the topic optimum global image segmentation using Otsu'S method. So before entering into the derivation, let's first discuss some basics. What is thresholding? So if you look at this histogram, this is basically the histogram of an image that consists of light objects in a dark background. So I want to segment this image. So one easy solution for that is to choose a threshold T. So this T is going to be a value in intensity range of the image. So I'm going to choose a threshold T such that in threshold, the entire image will be divided into two groups, the foreground and the background. So this is represented by the equation g of x comma y is equal to 1 if f of x comma y is greater than t, and it is 0 if f of x comma y is less than or equal. So this is the concept of thresholding. So there are different kinds of thresholding here. We're going to see the most important types. First is global thresholding. Here we are going to use a single threshold applied over the entire pixels of the image. The next is variable thresholding. So in the variable thresholding, as the name suggests, the value of the threshold is going to vary depending on the location of the pixels. So under variable thresholding, we have again two different categories. One is the local or regional thresholding. Here, the threshold at any point in an image is going to depend on the properties of the neighborhood of some. It can be the average or it can be the maximum of those pixels. So any property of the neighborhood of the pixel is going to be used to calculate the threshold at any point. That is local or regional thresholding. So next we are going to see dynamic or adaptive thresholding. So here the thresholding value depends on the coordinates themselves. We are not going to worry about the property or any other feature. We are just going to worry about the location of the pixel in the image. Okay? And finally we have multiple thresholding. If I want to divide or segment the image into more than two pixels. So initially we saw only two classes, right? The foreground and the background. If in case I wanted segment the image into multiple classes, then I need multiple thresholds to achieve that. In that case, thresholding becomes multiple thresholding. So these are the important types of threshold. Now initially, we are going to look at a simple thresholding based segmentation algorithm. This is titled the basic global thresholding. So what we are going to do in this algorithm is select an initial estimate for the global threshold T. So this thresholding is going to be global thresholding. What does it mean? We are going to use a single threshold value for the entire image. Okay. Select an initial estimate for the global threshold T. Then what we are going to do? We are going to segment the image using T. So all those pixels whose value is greater than t will belong to one class, and all those pixels whose value is less than t is going to belong to another class. So we are going to segment the image in such a case. Then what we are going to do, we are going to calculate m1 and m2. So what is m1 and m2? M1 is going to be the mean of all pixels belonging to class 1, and m2 is going to be the mean of all pixels belonging to class 2. So we are going to calculate m1 and m2 after the initial segmentation. Okay. Then what we are going to do, we are going to choose a new t based on the equation 1 by 2 m1 plus m2. So essentially, if my threshold is going to be calculated from this equation, what does it mean? My threshold is going to be exactly in the midpoint of both the intensity ranges. So thus, theoretically speaking, I will be able to obtain optimum threshold by this basic global thresholding algorithm. Now we saw the most basic type of thresholding technique. We are going to move on to the most commonly used segmentation method using thresholding. which is your Otsu'S method. Okay. So Otsu'S method is basically an optimum global thresholding technique that treats thresholding as a statistical decision problem. So here we are not going to assume anything. We are not going to make any kind of assumptions. All the process is going to be based on mathematical progression, which is going to make this method the most attractive algorithm of it. Okay. So the primary objective here is to categorize the pixels into two classes, as we have already discussed, the foreground and the background. So in Otsu'S method, we are going to use the between class variance as the important factor which we use to achieve the optimum threshold. Okay. So again, repeat in Otsu'S method, the most important factor is the between class variance. Okay. So, as I already suggested, this method is highly attractive because we are simply going to use the image histogram to calculate the entire process. So, this is a pictorial representation of the importance of histogram. So, we are going to take our image, convert it into histogram. So, now this histogram is going to be used as the probability distribution that is going to be used in the Otsu'S method. So, let's start with the mathematical foundation. Let us initially consider an image of size m cross n. So this image is going to have L distinct integer intensity levels. Let Ni be the number of pixels at intensity I. Okay. So what is going to be the total number of pixels here? The total number of pixels is going to be m into n. So where m is the number of rows and n is the number of columns. So if I multiply m into n, I will get the total number of pixels. Okay. So the first step in Otsu'S thresholding is to calculate the histogram. So what is histogram? Histogram is basically a measure of the number of pixels belonging to each intensity level. Okay. So the formula for the histogram is h of rk is summation I is equal to 0 to L minus 1 Ni, where Ni is going to be the number of pixels belonging to intensity level I. So I value is going to range from 0 to L minus 1. So this is the equation for calculating the histogram of the image. In the next step, what we are going to do, we are going to normalize the histogram. So how do you normalize any value? We divide the value by the total. So here, what are these values? These are totally the number of pixels, right? So the total value is going to be the total number of pixels m into n. So we divide ni by m into n. So this will give me the normalized histogram. So this ni divided by mn, we are going to call it as pi, the probability distribution. Okay. So now the normalized histogram is considered as the probability distribution of the intensity levels in our Otsu distribution. Okay. In the next step, we are going to choose threshold. So we are going to choose a random threshold initially. P of k is equal to k. So what is this k going to be? It is going to be a value between 0 to L minus 1. Okay, it's going to be one of the intensity levels. We are going to choose this randomly. So this can be even the average of values. So it's going to be a random intensity level present in the image. Okay. This is the initial segmentation threshold that we are choosing. So based on the k value, we are going to divide the image into two classes, class C1 and class C2. So class C1 is going to consist of all the pixels with the intensities in the range 0 to k. So you have all the pixels in the image. All the pixels whose intensity value is going to be between 0 and k is going to form the class C1. Class C2 obviously is going to be the group of all pixels whose intensity levels is in the range k plus 1 to L minus 1. So we have formed the two initial classes C1 and C2. After this, we are going to calculate class probabilities and means. Okay. So what is the class probabilities? It is going to be the probability that a given pixel belongs to a particular class. So we are defining two values, P1 and P. So what is P1? P1 is the probability that the pixel is assigned to class C1. So similarly, what is going to be P2? P2 is the probability that the pixel is assigned to class C2. Okay. So how will we calculate this class probability? We are going to use the cumulative sum of the histogram. So when we are calculating the probability of class C1, histogram is going to be equal to K because class C1 consists only of those pixels whose intensity is varying between 0 to K. So we are going to take the cumulative sum of the histogram only up to K. So P1 of K is going to be equal to summation I is equal to 0 to K Pi. So this is the class probability of class C1. Then P2 of K. So P2 of K, what is going to be the value? It is going to be K plus 1 to L minus 1. So it is going to be summation I is equal to K plus 1 to L minus 1. So obviously, since we have normalized the histograms, P1 plus P2 is going to be equal to 1. So P2 of K can also be calculated using the equation 1 minus P1 of K. So we have calculated both the class probabilities P1 and P2. Okay. Now, after calculating the class probabilities, we are going to calculate the class mean. So, M1 and M2. So, what is going to be M1? M1 is going to be the average of all the pixels belonging to class C1. And M2 is going to be the average of all pixels belonging to class C2. Okay. So, how are we dividing M1? We are using the standard equation for calculating the expectation I into the probability. Okay. So, since we are calculating M1, the range is going to be 0 to K. So, summation I is equal to 0 to K, I into probability of I given C. So, what does this probability talk about? It talks about the probability that the given pixel I belongs to class C1. So, we cannot calculate probability of I given C1 directly. So, to simplify equation 5, we are using the Bayes rule. Okay. So, what is the Bayes rule? Probability of A given B is equal to probability of B given A into probability of A, the whole divided by probability of B. So, now we are going to use this equation to calculate probability of I given C1. So, what will be the Bayes rule here? It's going to be probability of C1 given I into probability of I divided by probability of C1. So we are substituting the Bayes formula in equation 5. So we get equation 6 as such. So what is equation 6? Equation 6 is used to calculate the mean intensity of class 1. So M1 is going to be summation I is equal to 0 to K. I into probability of C1 given I into probability of I, the whole divided by probability of C1. Now, let us look at each of these factors. So, what is probability of C1 given I? Probability of C1 given I talks about the probability that it is class C1 given a pixel type. Okay. Since we are calculating the mean of class 1, all the pixels we are considering is going to belong to class 1. So, obviously, probability of C1 given I is going to be equal to 1 as only the pixels of class 1 are considered. So, what is probability of C1? Probability of C1 is nothing but the probability distribution of class 1. So, we have already calculated this in equations 3. So, what is this? This is the probability of class 1. So, we are substituting probability of C1 P1 of K. What is P of I? P of I is the probability distribution of the pixel I. So, we are replacing P of I with Pi. Okay, so substituting all of these concepts into equation 6. The equation gets reduced into summation I is equal to 0 to k, I into pi divided by p1 of k. So probability of C1 divided by I becomes 1. So we are not using that here. So P of I becomes Pi and P of C1 becomes P1 of k. So this is the equation for calculating the mean of class 1. Similarly, what is going to be the equation for calculating mean of class 2? It is going to be the same thing. Range is going to be what? It is class 2. So the I is going to range from k plus 1 to L minus 1. So M2 is going to be equal to summation I is equal to k plus 1 to L minus 1 I into P of I divided by P2 of k. Okay. So this is equation 7. we have calculated all the local parameters. Okay. So what are the local parameters? They vary with respect to the pixel. So now we are going to calculate the global parameters needed in Otsu thresholding. So what is global parameters? Initially, we are calculating the cumulative mean. Okay. So what is cumulative mean? It is the average intensity to level k. Okay. So m of k is going to be summation I is equal to 0 to k I into p of I. So what is p of I? P of I is going to be the probability of the intensity, and it is going to range from 0 to k because we are calculating cumulative mean to k. Okay. What is global mean? Global mean is the entire pixel range present in the images. So it's going to be mg is equal to summation I is equal to 0 to L minus 1 I into pi. Okay. So now we have calculated the global parameters needed. We have some relationships relating the local parameters with the global parameters. So it's going to be P1 into M1 plus P2 into M2 is going to be equal to Mg. So what is P1? Probability of class 1. What is M1? Mean of class 1. P2 probability of class 2. M2 mean of class 2. And Mg is the global mean. Okay. Since P1 and P2 are normalized, it's obvious that P1 plus P2 is equal to. So finally, we have arrived at the most important stage, the criterion for optimality. What is that we have to calculate to choose the optimum threshold in Otsu'S method? Between class variance. So what is the formula for the between class variance? Sigma b squared is equal to P1 into M1 minus Mg the whole square plus P2 into M2 minus Mg the whole square. So we already have formulas derived for M1, M2, P1 and P2. Okay. So we are going to substitute all of that in equation 12. So thus the equation 12 will get reduced to sigma b square is equal to mg into P1 minus m the whole square divided by P1 into 1 minus P. So when you compare equation 12 and 13, it is very obvious that equation 13 has got much simpler computations because we need not calculate P2 here. Okay. So this is going to be the equation that we use to calculate the between class variance sigma b. Next, the optimization and selection of the optimum threshold. So the objective here is to find the optimum threshold that maximizes the equation. So sigma b squared is going to be maximum of sigma b square of k. So now we are going to find the optimum threshold k. So how do we do that? We first go for calculating equation 13. Okay, we are calculating the between class variance from equation 13. After calculating this between class variance, we are going to calculate this for all values of k. So what is k here? K is going to be one of the intensity levels in the image. So we are going to calculate this K or this between class variance for all intensity values. We are going to choose that intensity for whom the between class variance is maximum. So that is going to be the optimum threshold. Okay. If in case we are not getting the maximum between class variance for any one intensity, what's going to happen then? We have to basically choose those intensities that give the maximum variance and we have to take an average of them. Okay. This is how the optimum threshold is chosen in Otsu'S method. Okay. Hope the concept is clear to all of you. So finally, after choosing the optimum K, we go for a segmentation. G of x comma y is going to be my segmented image. The value is going to be 1. If f of x comma y is greater than k, it is going to be 0 if f of x comma y is less than or equal to k. Okay, so this is one of the factors, separability measure. Beta of k is going to be equal to sigma b square of k divided by sigma g square. So sigma b square is the between class variance and sigma g square is the global variance. Okay, so global variance is we are going to consider all the pixels in the image. A sigma b square of k is going to consist of only those pixels up to a kth intensity level. Okay, so the formula for calculating the global variance is sigma g square is equal to summation I is equal to 0 to L minus 1 I minus mg the whole square into pi. Okay, this is a dimensionless measure. So finally, let us summarize the Otsu'S thresholding algorithm. Okay. So initially, we are going to compute the normalized histogram. Pi is going to be ni divided by m into n, where ni is the number of pixels belonging to intensity I, and m into n is going to be the total number of pixels. So I is going to vary from 0 to L minus 1. Then we are going to compute the cumulative sums P1 of k for all k. Okay. Then we are going to compute the mean m of k for all k. Then we are going to compute the global mean mg. Okay. Finally, we are going to compute between class variance sigma b square of k for all k 0 to L minus 1. So we are going to choose the optimum threshold, which is going to be the intensity value k, for which sigma b square of k is maximum. So if we are not able to get a unique k value, I mean single intensity is not going to give the maximum between class variance, what we are going to do, we are going to choose all the intensity which is giving the maximum between class variance and take the average of that. So this average value is going to be the optimum threshold. Okay. So using this threshold, we'll go for the binary segmentation. Thus, we are using Otsu'S thresholding method to achieve the binary segmentation. And we have got two classes, the foreground and background. So, hope the concept is clear to all of you. Thank you.